I'm going to show how to solve this problem right here. We use a T-chart strategy. Sometimes they only want the students to actually find the equation, so that's what we're going to do here. So this one says, Miss Spears' third grade class made 87 cookies for a party. When the party was over, there were 12 cookies left. Which number sentence could be used to find the number of cookies eaten? So what we would do is we would do our T-chart. Up here we put everything that we know. We write down one word up top about the topic of what we just read. So this one would be cookies that we would write down. And then we go one by one and kind of write down. So we know that the class made 87 cookies, so that we write down the word made because that helps us know what we're starting with. And then when the party was over, there were 12 cookies left. So we would write down 12 left. Maybe right here. Normally we kind of put dots to organize. 12 left when party over. And there's nothing else we know. And the only thing we put over here is what we don't know. It's what they're asking. And it says which number sentence could be used to find the number of cookies that were eaten. So I'm going to come over here. They want to know the number of cookies that were eaten. In this bottom left section, we represent it. We show it with a strip diagram. So the students have to ask themselves if they know their total. We're always going to draw our total box first. Sometimes they'll put the total on top. Sometimes it'll be on the bottom. But when we draw it ourselves, we'll just put it on top. And the total is, in this case, is what we started with. So the total was 87. And we have two parts. It's the amount that was left over and the amount that were eaten. If we combine those two together, we'll get what we started with. So I don't know how many were eaten, but I do know that I have 12 left over here. And they don't even want us to solve it. Right here, it actually has 4 equations because the question was which number sentence could be used to find the number of cookies eaten. So what the students do, they don't look over here and guess. If this is a one-step addition or subtraction strip diagram, which this is, and one step meaning that there's only 2 parts in one whole, then we go ahead and I have the students write 2 addition equations and 2 subtraction ones, and then they'll match it. So this makes 2 addition and 2 subtraction equations. Now, when I'm adding these two together, my total will always be at the end. And I can just flip the order of these. That's one of the properties of addition. I can take how much was eaten plus how much was left over, and that will get me my total of 87 cookies. Or I can flip these two, and I'll have 12 left over plus however many were eaten gets me 87. But this also represents 2 subtraction equations. So I start with 87. Our total goes first every time we're subtracting here. So I could, again, just flip the order and I'm going to get the same answer. The total minus however many were eaten tells me how many were left over, or the total minus however many were left over gets me how many were eaten. And then when they come over here, they would write A, B, C, D on their paper, but it would say our 87 plus 12 equals however many were eaten. Well, if we look at our 2 addition equations that we created, we're not adding to our total. And we know to find this number, we're not adding 87 and 12. So A would be false. Then we go to B, and B says we take 87 minus 12 equals how many were eaten. And that one is right here. That one does match, but we're going to be careful. This one is not even addition or subtraction, that's division. So we haven't got to that sign yet, but the students hopefully would say, nope, that doesn't make sense. And this is definitely not multiplication. This is an addition and subtraction problem. So the answer would be B.